by my original plan, this video was going to come out 2 weeks ago. At least 2 weeks ago. It was going to be simple, constrained, a reasonable amount of work. But then I started reading the comments in the first video about the 3dlabs video cards, and people kept saying, oh, I used to play Doom 3 on this card, and I used to play Doom 3 on that card. And people kept calling out these cards, and I look at it and say, like, oh yeah, I have one of those, or something very similar to that. And I have one of those, and I thought, every time I read one of those, I just added another card to the pile. And then it turned into, this is just part of it, it turned into quite a pile. So this was originally going to be the 3dlabs cards versus like 1 or 2 NVIDIA cards and 1 or 2 ATI cards. And it turned into the Battle of 4 Armies. Before I introduce the combatants, or the battlefield, or what they're fighting over, I want to respond to one of the other comments that I had on the previous video. Someone had asked me about the t-shirt that I was wearing. So this was a t-shirt that I got at SIGGRAPH 2012 in the OpenGL Birds of a Feather session to celebrate the 20-year anniversary of OpenGL. And this is one of a few shirts that I've gotten at conferences that is actually kind of special to me, because at this point, SIGGRAPH is usually like end of July, beginning of August. So I was a month and a half or 2 months from having worked on OpenGL for 10 years. And so it was kind of a neat shirt. Somewhere I have a thing that is sort of like an OpenGL yearbook that has this map on it. It has a bunch of other kind of fun stuff inside, little bits of trivia about OpenGL and milestones and things like that. So yeah, I wanted to actually show it off properly on camera. So you will certainly remember from last time the 3dlabs Wildcat VP990 Pro, such a mouthful, and the Wildcat VP560. Now, they're not gonna just fight with each other. Oh no, they have multiple armies coming after them. From ATI, we have a Radeon 9100, a Radeon 9250. This card is a little bit interesting because it's PCI and it has 256 megs, but it's a 9250. I think that is the 9250 PCI, I think, is the lowest end of the whole R200 family. Then to represent the R300 family, this is an all-in-wonder Radeon 9600. Now, in GPU-Z and in all the driver info, it just says 9600 series, but I looked up the PCI ID, and it is the PCI ID for a Radeon 9600 XT. So this is a Radeon 9600 ST. And then, of course, the general of the ATI Army, the Radeon 9800 Pro. Is this one the Pro? Yes, it's the Pro 128. There was another Pro that is a little bit faster, the 256, and it's faster because it uses, instead of using regular DDR, it uses GDDR, but they are not very common. I do not have one of those. Now, of course, if ATI is going to show up, you know NVIDIA is coming. So we've got a whole army of NVIDIA too. I only use this card in one of the benchmarks, and I'll talk about this when we get to that benchmark. But this is a GeForce 4 MX 420. Now, the GeForce 4 MX is really a GeForce 2 MX, just with, I think they changed something about like the video codecs on it. It is a super minor tweak, but from a gaming perspective, it's a GeForce 2 MX. Have an original GeForce 3. This was from before they decided to put numbers and TI around things. A GeForce 4 4200 Ti. Now the fan is disconnected because it does not work super well. I discovered that a lot of these cards need some minor repairs. Anyway, another fabulous card. This is a GeForce 5200 PCI 128. The 5200 of the whole GeForce 5 GeForce FX line. This was the bottom of the barrel. This was the lowest of the low. And this one also needs some repair. I can see these two caps here are bulging a little bit. And then the Marshall of this army is the PCX 5900. So this is a GeForce FX 5900 with an AGP to PCI Express bridge. It's sort of a middle of the road one of these based on its stats. It's kind of in the neighborhood of a high-end 5700, maybe a 5800. Like a bunch of the clocks are really low, but it is the full core. It has all the features. But wait, I hear you say, this is but 3 armies. Well, also showing up for the fun. I've recorded this a couple times and I've tried really hard to do this part with a straight face, and I just can't. I have a Matrox Perhelia. This is a P650, I want to say. It is the low end Perhelia. Now let that sink in for a minute. It's the low end Perhelia. And everything you've heard about this chipset, this is the crappy one. But it wouldn't be an army if it was just one soldier. So I also have a PCI Express Perhelia. This is the more full-featured core. I was not able to find out a lot of information about these cores and like clocks or number of pixel pipes or anything like that. There's not a lot of information about these, and likewise about the Wildcats. And GPU-Z has nothing to say about them. If you run GPU-Z, it just comes up blank. Like they couldn't even be bothered to look up the PCI ID on the card or look up the OpenGL. Like you can query that from the running software on the system. You could give some information. Nothing. You get nothing. All right, whatever. Okay, so the battlefield is... I wanted to make as much of an apples-to-apples comparison as I could. So what I have here is an ASRock 939 dual SATA 2 with an Athlon 64 X2 4800. So it's basically the second fastest socket 939 CPU. There is one faster, the Athlon FX, either 60 or 65. I don't remember off the top of my head. You can still buy those on eBay, and they are a pile of money. I bought this board and CPU new back in the day before I was working for Intel, when I did more open source graphics testing across a variety of different architectures, and I wanted a board that had both PCI Express and AGP. Now this other goofy slot here is for an upgrade card that allows this board to be upgraded to an AM2 processor, and it has DDR2 sockets on the card. I had an opportunity to buy one of those years ago. I saw it come up, a listing on eBay. A guy had 2 of them in the UK. It was a good price, but it's going to be like $50 shipping. And I was like, I'll be able to find one that's not $50 shipping someday. Yeah. Good choice. I saw one come up last year on eBay with one of these boards, and I think the combo of the board and the upgrade card sold for like $500. Like, it was a ridiculous amount of money. So I have no expectations that I will ever have one of those cards in my possession. Now, as far as what they're fighting over, I picked a variety of games that I played back in 2003, 4, 5, that kind of era. So of course, Doom 3. Also, Warcraft 3, which was a huge pain in the behind to benchmark. It has the CD key on it, so I'm not gonna give that away. Unreal Tournament 2003. I played a lot of 2003 and 2004. I was going to include Half-Life 2, but I found out a little bit too late that you basically have to jump through flaming hoops to be able to install Half-Life 2 on a Windows XP machine. When you install it from the CD, the first time you run it, it launches Steam. Even though you installed it from disk, it launches Steam and says, we have to check for updates, or I don't know, whatever it's doing. And so the Steam that comes on this tries to connect to the mothership. The mothership says, I don't talk to you. And so Steam says, the mothership won't talk to me. Well, you can't launch Half-Life. So that's frustrating. There is a way to install it. Had I known about this other way sooner, I probably would have done it, but it was not in the cards this time. Maybe when I do another, circa 2003 video, I'll get this installed. At some point, I'm going to do a video where I'm going to talk about the process that I went through to set up this system, because I came up with something that I think is a little bit clever that helped me. One of the problems with Windows XP is with a lot of these cards, when you install a driver for one and then either uninstall it or just install another vendor's driver over top of it, there's cruft left behind and it messes with system performance. And I didn't want to have to go through and reinstall every single time. So I came up with a method to sort of streamline the process. I'm going to save that for a different video. Being the completionist that I am, I ran Doom on all of these things in every possible rendering mode that was available. There are a number of modes available. By running the console command, GFX info, it will dump out a whole bunch of information about the graphics card, including what rendering modes it's capable of. Then using the r_renderer variable, you can select a specific mode. So saying r_renderer NV10 will select the NV10 rendering mode. Now there are a total of 5 rendering modes. There's ARB2, which is the preferred path. That is the path that, like I mentioned in the previous video, requires ARB vertex program and ARB fragment program. There's R200, which is a mode specific that uses a couple ATI extensions and is specific to the R200 family of cards. There is the NV20 mode, which is the similar kind of mode to the R200 mode, but it's for GeForce 3 and GeForce 4 kinds of cards. There's the NV10 mode, which was added specifically for the GeForce. In documentation that I have read, says it was added specifically to support the GeForce 4 MX. And if you're looking at this graph at all, you can see that's a little bit of a joke. I'll get to that in a second. And then there's the ARB mode, which is just use straight fixed function, no bells and whistles. It has the least rendering quality, in some cases has the least rendering performance as well. But it should run on pretty darn near anything. So I ran everyone through all their modes just to see, is there a difference in rendering quality? Is there a difference in rendering performance? What are the trade-offs? And I found a couple interesting things. So first of all, looking at, say, the Radeon 9600 in the ARB2 mode, that is both the highest quality mode and the fastest mode, similar for the Radeon 9800. The R200 mode is the slowest mode, and then the ARB mode is, just a scratch faster. Now that flip-flops around for the 9800. There's a bunch of weird things between 9600 XT performance and 9800 performance that we'll see as the video goes on. Now you may be looking at this and saying, hey Ian, why why is there no bar up here for NV20 on the 3dlabs cards? Well, how good of you to ask. Because that mode was not available. And I found that very confusing. Architecturally, these cards are very similar to the GeForce 4. The way that the fragment pipeline that I talked about in the previous video is split up in this phase of floating point operations to calculate texture coordinates, and then a bit of fixed function that does the actual texture lookups, and then another programmable stage to do stuff with the data read from the textures. Like, they're both very similar. And that, at least part of that has existed in the NVIDIA cards since the original GeForce. The GeForce 3, extended it and added another extension. So the original GeForce and GeForce 2 and GeForce MXs have a thing called register combiners. And that's that final bit of combine the texture data and do stuff. GeForce 3 and GeForce 4 added the bit before that, and they called that like NV texture shader, I want to say. And so my first thought was, okay, well, I've looked at the extensions list for these cards, and I know that it doesn't support the texture shader extension. So maybe that's the problem. Maybe it doesn't support that feature. Okay, well, so I did what anyone would do. And I thought, well, let's find out. And I went and I looked at the Doom 3 source code. Okay, so this is the GitHub page for the original Doom 3 source code release. And we're going to come down to renderer. I thought, okay, so I'm going to look through here. And I've never looked at this source code before, but there's some very conveniently named files. And I thought, all right, well, I bet the stuff about the NV20 mode is in this file called draw NV20. So I came in here and I just kind of started looking through it. And I came across, down at the bottom, there's a function called rNV20 init. Like, all right, so let's look at that. Let's see. So it wants register combiners. Wants ARB Vertex program, and 3dlabs decided to not make ARB Vertex program available. Literally, almost every other Vertex programming interface that they could have made in OpenGL, they made available, just not the one that Doom wants. Now, the other interesting thing here is that it's looking for at least 4 texture units. Now, I'm going to go to the draw NV10. I know it's just down at the bottom. So down here, all the NV10 path looks for is register combiners. Now, looking at the performance of all of the NVIDIA cards, except, where is it? Except for the GeForce 4 MX. All of the other cards support both the NV10 path and the NV20 path. And you'll notice something about this. GeForce 3, NV20, faster than NV10. GeForce 4, NV20, faster than NV10. GeForce 5200, NV20 is faster. GeForce 5900, NV20 is faster. So I have a hypothesis about this. And my hypothesis is that there's 2 differences practically between the NV20 path and the NV10 path. Now, I haven't looked. That little bit that I just showed is basically all of the examination that I have done of the Doom 3 source code. My hypothesis is that because the NV20 mode requires more texture units, because all of the GeForce 3 and later had at least 4 texture units, and all of the previous chips only had 2, my hypothesis is that, 1, using those extra texture units, it can do more work in each rendering pass, and so it has to do fewer rendering passes. It's very common in 3D graphics to draw a scene and then draw some stuff over top of it to add things to it. But if you can do more work on each pass, you can make fewer passes, and it should be faster. My other hypothesis is that the NV20 path, because it depends on Vertex programs, does a lot of stuff on the programmable Vertex hardware, and the NV10 path, I'm going to guess, has to do a bunch of that work on the CPU and re-upload data to the card after it's, recalculated various things. So that means, one, it's doing stuff on the CPU instead of doing it on the GPU. And two, it means it's shoving data across the bus every draw call, potentially. Both of those things are significant hits to performance. And we're going to see later, the strongest point of the 3dlabs cards is their Vertex processing. But between not having our Vertex program and not having Vertex buffer objects, they can't use the programmable Vertex hardware. And two, they have a slow path for shoving that data across the bus up to the graphics card. So it gives them a double hit. Now, I measured the difference in performance between all of the NVIDIA cards between the NV10 and the NV20 path. And it ranges from about a 15% improvement on the GeForce 3 up to like a 70% improvement on the GeForce 5200. Not having to shove that data across the slow PCI bus, right? The 5200 is the only card of these that is connected across the PCI bus. So it seems logical that it's going to get the biggest boost of not having to shove data across the bus every frame. So architecturally, I think the 3dlabs cards are most similar to the GeForce 4 cards. And the GeForce 4 cards got a 27% speed up. So looking back at this table, what if 3dlabs had provided the correct software APIs? What could the performance have been in Doom 3? Well, if we scale up the NV10 numbers by 15%, okay, so the performance is still bad. It's still sub 20 frames per second. I think the 990 Pro, this value right here came out to, I think it was like 18.9 being scaled up. So they're still it's pretty rough. I caught some flack in the previous video. I'm going to mention some more about this later. I cut some flack in the previous video about, of course it can run it. I mean, yeah, it can run it, but it's more like walking. It's more like some guy's grandma slowly making her way down this is not running. This is not, you're out, you're moving your feet, you're doing it is not running. No offense to grandma. Offense to these cards. All right. So Unreal Tournament kind of repeats the same thing, although I feel like the 3dlabs cards fare a little bit better here. I mean, they're definitely, the 990 is solidly playable. Bot match gets over 50 frames a second, so that's good. All these were run with just the default, literally the default out of the box settings at 1024 by 768. Now, part two of me defending myself against the people saying, you big dummy, of course it can run Doom 3. When I first ran this benchmark on the 3dlabs cards, and only did this occur on the 3dlabs cards, it would go through the benchmark for a bit, and it runs the game, comes out, runs another demo on it, keeps doing this thing, and it switches back and forth between the game's resolution and the desktop resolution. And I had the desktop resolution set at 1080p because that's what the monitor was. And at some point, when the sub demo was done, it would crash. It would crash hard and just reboot the system. Not even a blue screen, just JK, we're gonna start over. Bad drivers were a thing, folks. And so the question of can it run isn't is the hardware capable of it? It's were the drivers good enough for it? And if the drivers are struggling to change screen modes, I feel like my suspicion was well placed. What I eventually did on this, after when I got into the Warcraft 3 benchmarks, I noticed this phenomena again of the system crashing. I set the desktop resolution to 1024 by 768, and then the benchmarks ran just fine. But it was very frustrating getting there. Speaking of Warcraft 2, I ran Warcraft 2 in 4 different modes. So first, I downloaded a demo of some, what was it, 2 versus 2 competitive online play of this game. It was difficult to find a recorded demo that was from a version old enough that it would run on these cards. So I have links down below to the demo that I used and to the specific patch that I used. I want to say it was 1.26a. Warcraft 3 doesn't have a built-in benchmark mode, so to get these numbers, I had to use fraps. And what I did to try to get some stability in the numbers was I would start the demo, I would switch it into follow mode, so that it would track what one of the player's views was. I would turn it up to 8x speed. I had read a number of online reviews from back in the day, and that was people ran it at 8x speed because it pushes the graphics card a little bit harder. And I waited until 50 seconds into the time of the demo, which at 8x speed goes by a bit faster, to hit F11 to start fraps recording. And I had manually set fraps. There's a config operation option in fraps so that it will stop recording after a certain number of seconds. And so I set it for 93 seconds. So if I hit F11 somewhere between 50 and 54, fraps would stop recording right before the end of the demo, which is kind of the peak intensity. And so I did that 3 times for each. You're maybe starting to see why this took so long. For each of these cards, in 800 by 600 in DX8 mode and OpenGL mode, and in 1080p in DX8 mode and OpenGL. So yeah, it took a while. It took a while. But collecting the data like that, I think I got credible data that can be compared. Now, I ran Warcraft 3 has an OpenGL mode for 2 reasons. One, because it shipped on the Mac, and at that time, Macintoshes only supported OpenGL. Blizzard started supporting the OpenGL mode on PCs so that people could play better in Wine, because the DX conversion in Wine back then was not great. But for OpenGL, it basically just passed the commands through, and things ran pretty well. And I seem to remember fixing a couple of driver bugs in the Linux R200 driver in that time frame for this game running in that mode. So I wanted to benchmark that because I had a suspicion that 3dlabs probably spent more time optimizing their OpenGL driver than their DX driver. So maybe OpenGL would perform better. I don't know. But what I got was kind of interesting, and I think I have an explanation for it, and that's that the ATI drivers tend to perform better in OpenGL mode. So in 800 by 600, the 9250 performs a lot better in OpenGL mode than it does in DX mode. And the 9800 also performs a little bit better. And other cases, it's pretty close. And with the 3dlabs cards, it's pretty close. What surprised me, NVIDIA has always prided themselves on the performance of their OpenGL driver, and like on the 9250, there is a massive, or the 5200, sorry, other low-end card. On the 5200, like the OpenGL performance is less than half the DX performance. And the 5900 has a pretty big hit. The 4200 Ti has a pretty big hit. And the GeForce 3 has a significant hit. Now, the Perhelia having like a giant gap, taking, that 50% performance hit, going to OpenGL mode, that surprises me zero. It gets a little bit more weird going to 1080p. So, I had a hypothesis about this, about the NVIDIA situation. After I had gone into OpenGL, because of the order that I did things, I did DX at 800 by 600, DX at 1024 by 768, and then I switched to the OpenGL renderer at 1080p, and then down to 800 by 600. I could not get the NVIDIA driver to switch in OpenGL mode to switch back to 16-bit mode from 32-bit mode. So all the numbers on the NVIDIA cards are actually 800 by 600 in 32-bit mode for OpenGL. It's 16-bit for DX, and so I thought, well, maybe that's why the performance is so janky. But then going to 1080p, everyone is rendering in 32-bit mode, and the performance drop is worse. I mean, this drop here on the 5900 is just like, what? Like, it's more than half. What happened? Why is this? So maybe, there wasn't a lot of NVIDIA hardware on Macs. There might not even have been any NVIDIA hardware. So perhaps in OpenGL mode, Warcraft 3 is trying to use ATI-specific extensions for performance that don't exist on the NVIDIA cards. I don't know. But at 1080p, OpenGL is faster on every ATI card and on both of the 3dlabs cards, which I thought that was interesting. Now, the VP560, it's kind of a clinker.
It's a clinker!
It's faster than the slowest Perhelia. Well, it's about the same speed as the slowest Perhelia, and it's faster than the 5200 in OpenGL mode. Other than that, it's a clinker. The VP990 Pro does reasonably well, but it's a $1,200 card. Like, it's kind of... Anyway, I'm underwhelmed by the performance of it here. This is sort of the bad news section. Now, the good news section, where these cards should shine, is in professional workstation kinds of benchmarks. Now, I didn't have any apps of my own to run for this, so I picked on Viewperf, like I did in the previous, the 3dlabs GMX 2000 video that I did. Must have been over a year ago, long time ago. Actually, it's the same version of Viewperf. I think that there was probably a newer version that's more appropriate than this, but I didn't. I used the version that I had handy. Now, Viewperf is made up of application traces from 4 different kind of workstation apps, and it just replays captured OpenGL commands. It is definitely the case where the 3dlabs card, it's what they're designed for. It's where they should shine. And right out of the gate in the first benchmark, which is kind of it's mostly this 3D model of a guy spinning around, it did really well. Like, the only cards that beat it were the R300 based cards, the 9600 XT and the 9800 Pro. It severely beat all of the NVIDIA cards. Even the Radeon 9100 beat all the NVIDIA cards, and I find that very curious. I'm a little bit suspicious about this 4200 Ti score and the 5900 score. They are right at about 60 FPS, so I'm wondering if running in OpenGL mode like this, if these were VSync locked, and so they were capped at 60 FPS. I don't know. And I didn't look at this data until it was way too late to go back and poke around and try to collect more data. But it seems very suspicious that both those cards were both like, I think the average there is like 59.8 FPS for both of them. But other things, we're getting way more, other OpenGL applications were getting way more than 60 FPS. So I have questions. One of the other traces, the the VP560, the slowest of the 3dlabs cards, just wrecks everyone else. Like it's like twice the performance of the 5900 and the 4200 Ti. Like that's significant. I did find it very odd that the Radeon 9100 beat both of the R300s. And so again, for these, I ran each of these benchmarks 3 times. And there were a couple of the cases where I think, especially on the GeForce 3 and one of the other GeForces, where every now and then there was a test where like it'd run twice and get a score of 20, and then the third time it'd get a score of 5. So I threw out those real outlier scores, and the remaining scores are averages, and they were all like, it was a very small standard deviation in all the cases. So I believe these numbers. So DX is an interesting case that I want to go back and check, because these were long-running things, and I did not sit and watch them. I am suspicious about those VP990 numbers. That seems way too high. Like, it is more than double the performance of the 560, and that is suspect to me. I don't know. But again, the 4200 and the PCX 5900 have almost exactly the same numbers. So maybe those previous values of 60 were legitimate, and it's just a coincidence. Correlation does not necessarily imply causality. I'm a little bit surprised at how well the Parhelia cards did. Like, they beat the 5200? Like, how did they beat anything? Okay, so Light is an interesting case. Light is playing back radiosity renders. Radiosity is another global illumination technique. I don't want to say it's similar to ray tracing, because it's not. It was used in similar ways as ray tracing. And so kind of what you end up with is these giant points of how much light is at a certain spot in the scene, and there's a variety of ways that you can render those. And in one of the render modes of this, it's shoving huge numbers, huge amounts of data across. I believe the way that it is rendering is it renders a ton of really tiny polygons. So it's just sending a bajillion polygons. And so the PCI Radeon 9250, this score down here, that is 2 seconds per frame. Yes, that is 0.5 FPS. And the 5200 is, similarly very slow. I'm assuming because it's trying to shove a huge pile of data each frame across the slow PCI bus. And the AGP and PCI Express cards just crush it. And I suspect that's why the faster Parhelia, which is on the PCIe X16 bus, like, it's just how much data can you shove across the bus, and it does really well. Now, I think the reason the VP990 Pro does so well is I suspect this application uses an OpenGL feature called display lists, which is a very old feature that lets you store drawing commands on the card. I think this particular trace uses display lists, so it puts all the drawing commands on the card, and that 990 Pro has 512 megs of RAM, so it can hold a lot of data on the card. So then the next frame, it's like, oh yeah, all that data is already here. I don't have to transfer anything across the bus. slow PCI bus, slow AGP bus. Psh, that's for chumps. And it just draws it from the on-card memory. That's my guess. And that is my guess as to why that card does so much better than the other 3dlabs card. I mean, it shouldn't be, I mean, that's more than a 2x difference there, and it shouldn't be 2x faster. Like, it hasn't been 2x faster at anything else. So I think this is the one test where the 512 megs of RAM actually do something for it. So there it is, folks. That's what 512 megs of RAM gets you. And again, the PCI Express cards did well, and then the R300 cards, you know, they're just fast, and so they did really well also. The MedMCAD draws this weird visualization. I'm not sure what it is. In a few of the modes, it's drawing a very, very dense point cloud, and then it draws the same thing, but as like wireframe and filled polygon modes. And again, I think this is a case where on the VP990, all that data just gets cached on the card, and it gets to draw it really, really fast from the on-card memory. And the 990 Pro just beats everyone. And then the final ViewPerf test is the ProCDRS. In this demo, it's the rendering of a couple of pickup trucks, and it goes through a bunch of different modes: wireframe, smooth shaded polygons, a couple of texture mapping modes. And the 990 Pro beats everyone except the R300 cards. I'm starting to feel a little bit like a broken record here. Just handily whoops all of the NVIDIA cards. Even the slowest 3dlabs cards, the VP560, just smokes everything from NVIDIA. I mean, I guess it's about the same as the 5900, but everything else just cannot even compete. So where does that leave these 3dlabs cards? I mean, at games, not great, right? I don't think that I would particularly play Warcraft 3 on any of these cards, not competitively. I wouldn't play Warcraft 3 competitively. But maybe the 990 would be all right. It in a way, it feels like an overkill card for that. And at any of the other cases, it just, I mean, Unreal Tournament scores were decent enough. I feel like these cards are hobbled by their drivers. I think the hardware is better than the drivers allow them to be. In the OpenGL applications, they're missing some extensions that would definitely help performance. I mean, performance at Doom 3 would still... I know a lot of people said that they played through Doom, all the way through Doom 3 in like the teens frame rates, but that just... I feel for you. I feel for you. I dug through some of my notes and some of my records, and I think I played through Doom 3 on a 9500, on some kind of 9500, and I think it was on that motherboard. But I'm not 100% sure. It's like digging through back some of my notes and like emails where I was, telling people I was having LAN parties and things like that, and trying to piece together what did I play that on. I don't think I would want to use this now. Not for that. And even at the kinds of applications that it's designed for, as long as you're vertex processing limited, these cards shine. Any other scenario, duds. Like, they got beat out by the R300s, even the 9600 XT. I regret, as late as this video is and as much work as it was, I did not have a chance to actually try to write any software for this. I would still like to do that. Someday there may be a part 3. Another thing that I think would be interesting is both, I didn't talk about this when I was going over the benchmarks, but the Perhalia cards also in Doom 3 only got the ARP mode, and they can definitely do, hardware-wise, they can definitely do the R200 mode. They also just made some weird software choices, and so Doom 3 can't utilize their features. Now, I don't know. On the ATI cards, the ARP mode runs faster than the R200 mode, even on the R200 cards. So I don't know if I want to turn the especially on this card, what were already single-digit FPS. It might look prettier, but it would be a slideshow. But given the availability of the Doom 3 source code, I think a person could modify the Doom 3 source code to be able to run the NV20 mode on these cards and perhaps run the R200 mode on these cards. I think the way to do that, the way that I would do that, would be to write a software layer that would take NV-Vertex program and cross compile it either into, take ARB-Vertex program and cross compile it either into NV-Vertex program, which I think should be doable, or into GLSL. So convert assembly language up into high level language. It's a weird thing, but I think that would enable vertex shading on these. It still doesn't solve the slow vertex cache problem, which is due to the lack of vertex buffer objects. There may be some ways to solve that also, but it would require much, much deeper surgery into the Doom 3 source code. I think a similar thing could be done with the Perhalia cards, but you would have to do it both for vertex programs because they only expose a really weird, clunky vertex shading extension that ATI shipped for about a minute, and they have their own sort of equivalent extension to the ATI fragment shader that ATI shipped on the R200 cards. So you could make translation layers for those too, and just have like a standalone library that sits in between Doom and the OpenGL driver, and it would just work, and you wouldn't actually have to dig into Doom 3 source code itself. But that's a project for a different day, and probably not a project for me, although it is going to nag at the back of my brain for years. If you enjoyed this video, and if you appreciate the ridiculous amount of time that I spent benchmarking all of this crap, I would really appreciate it if you would click the like button. If you are interested in seeing more content like this, I have a bunch of similar and also very different stuff planned in the future. I highly recommend that you click that subscribe button. My next video, I'm going to be looking at a vintage hard drive tester from Fujitsu that is on loan to me from a friend in the area. And then after that, I'm going to try to get back to the Spark stations. So, until next time, try to remember the good stuff.